Good afternoon, everyone. Trust you are keeping well and sincerely hope you're keeping safe. I'd like to welcome you, no matter what time it is. I see there's lots of people online from all over the world, so hope you're having a good morning or afternoon in Europe or evening in Asia and Australia if you're in that area. So what we're going to do today is give you an introduction into the ease programs that are available and what you can do with them, and how we help you with your system designs. So firstly, I would like to introduce myself. My name is Ian Hodgkinson. I'm an application engineer here at Biamp. I'm based in the UK and I joined APART in September 2009, and before that I worked with Biamp for 9 years, so a little bit of experience in this group. Also online is my colleague Raf Williams, so he is there predominantly to help with any questions that come up whilst I'm making the presentation. So please feel free to ask any questions in the dashboard that you've got for GoToWebinar. Also, you'll find in the GoToWebinar dashboard there is a PDF handout of the presentation already in there, so you can take a copy of that if you'd like to follow along with what we're talking about. Also, just to mention that there will be a recording available of the webinar probably in the next couple of days, and you'll get an email with details of where you can find that recording, but it will be sent to you as soon as possible. So firstly, what I'll do is start with an overview of Biamp and what we're all about currently. So the company was founded in 1976 with our head offices in Portland in Oregon. We have R&D centers in North America, in New York, Boston, Portland, then and also Philadelphia, of course. Then in Europe, in Antwerp, in Belgium, and in Modena in Italy now. And then in Australia, of course, in Brisbane. Manufacturing is done predominantly in Portland and in Philadelphia, and of course we have warehouses or factories in China that we also use. And support services all over the globe, as you can see by these dots. So you can see that we have very good coverage of the globe for sales and support of our products. And in fact, we're represented in over 120 countries by distributors and have members of our own team all over the globe also. So the verticals that Biamp cover, excuse me, currently, very good coverage of all different markets. So business is a very big part of our world with corporate meeting rooms and so on. Education also, government, sports venues is in there as well, predominantly nowadays with the community family of products. Healthcare, houses of worship, and transportation. Retail and hospitality is a focus point for the APART Audio product family, of course. So the different product families that we have within the group now have been branded as such. So Tesira is obviously best well known for AV processing and distribution DSP platforms. Parlay microphones as part of that system as well. DeSono loudspeakers, along with the APART and community loudspeakers, make a really nice set of products for all of your needs for loudspeakers. Devio for huddle rooms, along with Modena for the wireless presentation systems. And then, of course, Cambridge for the sound masking. And then other DSPs, Vocia, for example, and then Cambridge for helping with sound masking. SageView allows you to do remote monitoring and commissioning of multiple systems around the globe. And then Crowd Mics is a way of broadcasting a message and voting and questions and answers when you're making a presentation. And this can be done within a room using a mobile phone for the questions and feedback questions, but also now online so that you can host a meeting online and have it have participation all over the globe. So the solutions for all environments, so we go from individual rooms with a single Devio, for example, and or a DSP platform with microphones, up to background music, distributed audio, networked video, of course, with the audio on the Tesira and Vocia side, public address, paging and mass notification, then obviously staging and entertainment, and sound masking. So pretty much all aspects of the market are covered by the Biamp portfolio nowadays. So the subject of this webinar is about ease and how you can use it. So this is what we're going to be covering today. What is ease for? Who makes it? What is a GLL? So you may have heard people talking about GLL files. The different types of ease, how you use it, and a few system examples in there as well at the end. So what is ease for and who makes ease? So the word EASE is an acronym, basically stands for Enhanced Acoustic Simulator for Engineers. So in reality, technically, it is an acoustic modeling software which allows you to see on a screen how your sound will be before you make the installation, for example. And this allows you to experiment with the positioning and the type and the number of loudspeakers that you are thinking of installing into a project. So it assists with the audio system. It doesn't do magic and make every calculation for you. You still need to have some input on where the speakers go and what the expectations for the system are. But it does help you with loudspeaker placement, estimating the number of loudspeakers required, and in the end produces a graphical acoustic simulation representing how the sound will be in a space. This helps you to specify the equipment required, even if the space is not built yet. So in many cases, what comes out of an EASE simulation can help the designers of the building and the architects to build the space to be acoustically better, for example. And then ultimately for you, the installer or the designer, it helps to have your design accepted because it produces a very nice report at the end of the process, which goes along with your offer for a project, and therefore gives a bit more professionality, if you like, to the bid that you're making. EASE is produced by a German company called AFMG. They have many different software products available. Some of them are free of charge, of course, which we're going to summarize today. But then there are many of them which are also chargeable, and it's a very complex set of software that they produced. And the web link is there. But if you do a search for AFMG, I'm sure you'll come to the right place there. So GLL file, some of you may have heard this name bandied about, or this word bandied about. So we're going to dig into what exactly is a GLL file. So GLL stands for Generic Loudspeaker Library, and it's a computer file that contains all the data that is required about a loudspeaker. So that can be, for example, the simple specifications, the dimensions, the weight of the product. It also includes logical connections for mounting and rigging of the product so that it can be installed virtually, if you like, inside the software so that you can move the loudspeaker in all planes to get the best performance out of it. But importantly, it includes the acoustical performance, so how it responds when you apply a certain signal to the loudspeaker and what audio beam it produces out of it. It also allows electrical filters to be applied to the, or it has electrical filters built in so that you can apply those to make the sound even better in your project. So all of the Biamp GLL files are created in an independent lab, so the loudspeakers are taken to an anechoic chamber, subjected to a number of tests, audio tests and physical tests, of course. And then a GLL is created by this independent lab. So, and this is very similar for all other loudspeaker manufacturers. So it becomes kind of a standardized method of knowing how a loudspeaker will perform ultimately. And they're all done by an independent lab, I believe. So most loudspeakers from the Biamp range have a GLL file, and these are available for free on our websites. And I'll show you in a moment where exactly you can get those. It should be noted, however, that not all GLLs work with all types of EASE. So we're going to detail exactly the different versions of EASE that are available, or the EASE products that are available. But it's not always the case that a GLL file will work with every version of EASE. So you need to be careful with some loudspeakers not working in EASE Focus, for example, but yes, they will work in EASE Address. So here we're going to summarize the different versions of EASE that are available and how you can get hold of them. So as I said before, AFMG make a vast number of different software packages. The ones that are most relevant to us are these four here. So GLL Viewer, EASE Address, EASE Focus, and EASE Standard. So I am going to go into detail on what each of those does for you, but here in this list, note that they are listed in order of complexity and capability. So GLL Viewer is the simplest piece of software. E-standard is the most complex piece of software. But as I said, AFMG do have other pieces of software, but these are the ones that are most relevant to us. So GLL Viewer, this is how it looks in operation. So here, for example, I've got a simple balloon mapping of the response of the loudspeaker, in this case, an apart mask 6C. So important to understand, the GLL Viewer does not give any acoustic simulation at all. So it really just allows you to dig inside the data that's inside the GLL file. So the GLL file data can be simply viewed within GLL Viewer. And once you've installed it onto your laptop or your computer, you just open the GLL file to view the data. This is available free of charge from our download section. The link is here. And then what GLL Viewer typically allows you to do, the most useful things, or some of the useful things that we have, you can see the polar plots for the loudspeaker. So you can see how it's going to perform on its own in a space. You can see the sensitivity or the bandwidth of the loudspeaker, and you can see the horizontal map. But there's an awful lot more, including the physical dimensions and weight and so on, that you can view within GLL Viewer. So that's a great thing to have on your computer so that you can just very quickly see how a loudspeaker is going to perform on its own without any other loudspeakers in a room. And it gives you an idea. Or for example, if somebody asks you what the polar plots are at a particular frequency and a particular level, you can easily pull up the polar plots and track and calculate the figures for yourself. Ease address is the next step up. So you can see here a little bit more complex. And in this one, for example, on this screen, you can see there are 5 loudspeakers which are in place, and you'll get used to this way of looking at the loudspeakers. So the red obviously means a higher level, higher SPL level. The blue obviously means a much lower SPL level, but we'll go into that in detail later on. Ease address is not something we're going to go fully into detail here, but the principles that we talk about later in ease focus are easily transferable into ease address. So ease address is an acoustical simulation program, but it only concerns itself with 2D modeling of loudspeakers. And in this case, it's pointing down from the ceiling. So in this drawing, imagine that's you looking down on above a space where you've got loudspeakers pointing down into the room. So it provides the user, or you as the installer, detailed analysis of sound coverage, SPL, and frequency response. Again, available as a download from our support section. The advantages of ease address are it is extremely simple. So it's very easy within a few minutes to get up and running and have a visualization of how some speakers are going to sound within a space. It also has an auto arrange function, so that it means that you can put in the space size, put in the type of speakers you want to use, and ask the software to calculate how many speakers to cover the room. You do need to obviously be able to interpret those and work out that it's actually the correct solution for you, but it does a lot of the job for you. The limitations are, as I said, it's 2-dimensional only, so only ceiling speakers can realistically be used. It also only concerns itself with direct SPL, so it doesn't consider room acoustics or room finishes in any way. And of course, the simulation is only as good as the input data that you put into it. So, but it does give you a very good starting point for simple conference rooms, for example, with just ceiling speakers. The one that we're going to focus on today, no pun intended, sorry about that, is ease focus. So this is a little bit more complicated. But the advantage is it does give you 3D modeling of the loudspeakers within a space. So that means you can see not only from above how the performance of the loudspeakers will be and how they interact, but also from the side. So that means you can get a real good idea of where the sound, how the sound is going to be in every part of the space. It is based on AFMG's leading simulation software, Ease or Ease Standard, and therefore has a very wide scope of features and functionality. Very, very powerful piece of software. Again, available free of charge as a download from our support section. Advantages, it shows you the loudspeakers in a 3D environment. Limitations are direct SPL only still in the software. It does not consider room acoustics or the walls and floor finishes, so no reflections are taken into account. If you do need software to look at the room acoustics and reflections from walls and floors and the different surfaces you can use, that's where you need to go to the next piece of software, which is the full Ease standard software. So this is Ease standard. It's actually quite an older piece of software now. It doesn't use some of the latest Windows techniques for the graphics, but underneath the hood, it's an extremely powerful piece of software. It is 3D modeling for loudspeaker simulation. It is chargeable. It's not cheap. It's around about $2,280 the last time I looked. So it's not a cheap piece of kit, and training is definitely not needed. So it's not like Ease Address or Ease Focus, where you can install the software, have a little play with it, maybe do a small webinar like this and get running. Ease Standard, I think you need minimum of 3-day training course to get this up and running and working in the way that you would expect. But the results you can get from it are absolutely extraordinary. So you can download this, or you can get details of how you can get a copy of this from AFMG directly. The advantages are it does consider walls and pillars. So anything in the room can be taken into account in terms of the acoustic properties of the space. So it considers reflections, it considers wall and floor coverings, and indeed you can put in different types of wall coverings and floor coverings so that the reflections are very much taken into account in the correct way. Limitations, not really limitation, but it's very complex to install and use. So if you need the software and you're up for it, for the work that's involved in getting this working, it is extremely powerful. So you can get some great results. It is expensive, but you get what you pay for, and it does allow you to make some projects which you wouldn't otherwise be able to get. So the thing we're going to focus on, or we're going to look at heavily today, I have to stop saying that, is Ease Focus and how to use it and what it can offer you. So this is a screenshot of Ease Focus. This is how it is when you first install it. This is how it looks immediately that you've got it installed. So if any of you have got this software installed already or would like to get it installed, this webinar is going to take you step by step from a blank screen to getting some sort of visualization made. So some familiarization for you here. Firstly, we have the working area. So this is the view from above where you can add audience areas, i.e. places where people are going to listen, and you can add loudspeakers into the layout to see how it will sound, to see the results. You also have a scale here, and we'll talk more about scale in a moment. So that just shows you that each of those small squares is 4 meters in this case, in case you can't see it. And of course, the space, the listening area, you can change the size however you want to represent how your actual venue is. And you can change the shapes. There's various different shapes you can have there. There's also the working area toolbar here. So that allows you to zoom in and out. You can also use the control button and a scroll on your mouse wheel, for example, to scroll in and out. It also allows you to add a floor plan graphic so that you can put that in and have a real idea of what your room is gonna look like. You can add loudspeakers and you can add receivers, which are kind of like listening devices or microphones in some way, where you can monitor virtually how the sound will be at that point within the listening space. Then we've got a multi-tab display, which has various different functions, and I cover these in detail a bit later on. And then the tab selection, so you can choose with these tabs what is being displayed in that lower part of the screen. You have the objects properties selector and the project properties selector as well. And again, we cover those in a moment. So hopefully you can see, whilst there's quite a lot going on the screen. Oh, I forgot one thing. So on this top toolbar, these are the mapping settings, which allow you to choose the frequency response and the type of audio signal that's going to use for the visualizations. And very importantly, in the top left there, there's a button which says show mapping. So whilst you're putting loudspeakers into your design, it's a good idea to turn show mapping off so that it doesn't try and recalculate every time you move a loudspeaker. And then once you've got your loudspeakers in place, you can turn the mapping back on and it starts to do the calculations of what the sound will have to be. So quite a lot going on the screen, but if you break it down into these little sections, it becomes quite usable. So the process of getting Ease Focus up and running so that you can start your own project. So I'm assuming you've got the software, you've got it installed. First thing to do is you need to download the GLL files and import them and set the options. For each project, I'm sorry, that process before was a one-time process. So you do it once and then you're pretty much set for the next project. For each project, you need to set the project properties, import the floor plan, select the audience area, set the audience areas, add speakers, set the speaker position, and create a report. So breaking that down, downloading the GLL files, if you go to this link, support downloads, you select resource type as software, so that's a filter within the download section, and you will find in the apart section, which appears the apart ease address and ease focus software plus GLL files. So download that file. You've got a good start because you've got all of the apart audio GLL files. For the community ones with the same resource type, go to the community section, download community EF315. Then you've got all the community GLL files and ease focus. Then if you change the resource type to specs and drawings, you can then go in and get the Disono P6 and the P6SM GLL files. The Disono CIC6 files are actually in the specs and drawings section, which is slightly above. So if you download all of those files, then you've got to a really good place where you've got every one of the loudspeakers that we produce, or the GLL files for them. And just to let you know, this layout is a little bit under review, so we're probably going to make some changes in the coming weeks so that there will either be a resource type as ease GLL files, or they will all be in one file and much easier to access. So keep an eye on this. It may change quite quick in the near future. So once you've got all of your files, download them into a known folder on your PC, because often they go into a downloads folder, which you have trouble finding again. So I normally put them on the desktop, and then unzip them into a known folder. So something you know where it is on your laptop. So in this case, really important GLL files, and I know it's in a particular folder, so I can find it whenever I want to. Now, we've got the GLL files on our laptop. Now what we need to do is get them into ease focus so that ease focus can start using them and creating visualization. So in the ease software, go to File and Import System Definitions, or you can click Control-I. Browse to where the folder where you stored. So in my case, it was desktop, really important GLL files. So there you see a list of all of the GLL files that I've put into that folder. That's not all of them. I just wanted to make an example of all of the different files that we have. You can then select all of them by clicking Control-A. So they're all selected. And when you press Open, the files are imported. So you'll see this bar making progress until all the files are imported. So that's the GLL files all imported into ease focus. So that's a one-off thing you have to do, or if you get a new loudspeaker GLL from somebody, another brand maybe for comparison, or another product that Biamp produced. So next thing we want to do is set some options just to make the environment work in the way you want it to. So from the main screen, click File and then Options, or you can click F9 and it comes up with this option screen. So in the environment section, set the functionality mode to extended. And the reason for doing this is it just adds a few advanced features in there which are quite useful to have as standard. So this is things like, for example, output filters or 1/3 octave visualization to make it a bit more accurate to understand. The other parameter on here are for you to set as you want. For example, the language, the units of measure, whether they're metric or imperial, and so on. But out of the box, apart from the extended mode, it'll just work. So setting the project properties. On the main screen, click Project Properties, the button I showed you earlier on. You can enter the project title, so that could be the name of the end user of the project, the author, your name, your company name. And the reason for putting these in here is that at the end of the project, when we make a PDF report, this data will be included in there. Down the bottom here, you can also set the temperature, the air pressure, and the humidity as required. Now, these are standard figures, but if you know it's going to be warmer than that because of your outdoors, or for example, or the humidity might be different, then you can set it, because of course this data will affect the performance of the room and the loudspeakers within it. So then in the project properties window, click on the project settings. This is where you can set the ear height for measurement when people are sitting, standing, or at a custom height. So these are the default values. So you can change them to be whatever you want. So if you know that people are going to be actually a little bit lower than that for some reason, or the average level is going to be lower, you can set that here. Then later on in your design, you can choose whether the visualizations are done with sitting or standing or custom value. You can also set the upper and lower height limits for loudspeakers or sound sources as they're known in ease, so that if you know that there is a hard limit because of a ceiling at 8 meters, you can set that here. And that means it's not possible to put any loudspeakers above that point within the room. Similarly, you could have a lower height limit as well for some reason. Now, we've got all of our setup done. Now what we're going to do is start on a real project. So first thing we're going to do, if we have it, this is an optional step, but if you do have a CAD drawing or a graphics file of the layout of the space that you're working with, so for example, it could be the floor plan image of a retail outlet, that's great. If you do have it, we use it here. If you don't have it, it's not a problem. It just means you have to do a bit more manual work. The reason for having the floor plan image is you can then take into account where the walls actually curve round, for example, and place your loudspeakers accordingly, or you can take into account any doors or areas where, for example, there's a cash desk in a retail outlet or a changing area, for example. So if you do have the floor plan image, on the toolbar at the top of the main part of the screen, click on the layout picture button, select the room layout plan, and this has to be a graphics file, so it's not a PDF. You can't use a PDF in this case, so it's PNG, JPEG, GIF, BMP, things like that. But of course, if you only have a PDF, you could make a screen grab of that part of the drawing and then save it as a JPEG, for example. Now, this edit layout picture window will come up, so it shows you the graphic. So this is the graphic that I've imported. This is I think it's a canteen or something like that we worked on a little while ago. So what we want to know is, or what we want to denote here is a known distance within that drawing. So for example, so when this page first comes up, the A and B markers are down the bottom of the screen here. So what I've done is I've moved them to 2 points within the room, i.e. this outside wall in this case. So I've moved the A and B to those points because I know that in real life, the distance between those 2 points is 50 meters. So I've moved the markers to scale it. Another useful thing you can do if you don't have information about that is 50 meters, you can normally say that a door width is going to be 1 meter or 1.1 meters. So you can use that, or if you know that this desk is 1 meter wide, for example, then you can use anything in there to get the scaling as close as possible to accurate. But in this case, because I had a drawing with dimensions on it, I know that that distance is 50 meters. So I moved the 2 markers to represent the known distance. I then enter the line length on the right-hand side, i.e. in this case 50 meters. And then what it does is it goes back to the main screen and it's added that floor plan into your design automatically for you. Okay. So now we know that that is the room that we need to start working with. And note in the bottom here, it's got a scaling of 10 meters for each of the squares on the drawing. So that will work out that the space between A and B we had is 50 meters exactly. So now we know that we're working with a real visualization of the space we're trying to work with and to install loudspeakers into. So once we've done that graphic import, we now need to start adding audience areas. Now, the first thing to understand is that ease focus does not take walls into account. So in this example here, for example, whilst we have 2 distinct listening areas, and it looks like there is a line between the 2 rectangular listening areas, it doesn't, ease focus doesn't actually know whether it's a wall or just an open space. So it assumes it's an open space. So that means if I put a loudspeaker in one of those audience areas, the sound from it is going to project into the second one. In this case, it's okay because it is actually an open plan area, but in some cases it might be a problem. So if it is a real wall, a structure there, the best thing to do is to design or to create a project individually for each of those separate rooms and do visualization separately. Otherwise, you could get into some difficulties with the visualization not matching what's going to happen in reality. But anyway, we can set the audience areas, and you can see there with the circle at the top, we've got a rectangular room, but we also have different shaped audience areas, trapezoids, and so on. So you can make a quite complex layout according to what is actually reality in the real life. Just had a question from Mina. Does easeFocus import from CAD or it only opens images? Unfortunately, it only opens images as far as I'm aware. I'm just going to do a quick check. I have easeFocus open here, so I'm going to see what it does. No, it's only PNGs, JPEGs, GIF, BMPs, or TIFF files. So unfortunately, not directly from CAD files in this case. But of course, you can export them directly from your CAD file normally. Okay, so once you've put in your listening area, so for example, if I backtrack to this one, what I would normally do is make a listening area which covers this whole space with one listening area where all of these tables are for the cafeteria, for example. And then once I've done that, I can use the object properties to set the audience name. So I could say main cafeteria, for example, accurately set the dimensions. So if I didn't have the dimensions already worked out, then I could put them in here. And this is where I can set the ear height. So in this cafeteria, they're predominantly sitting. So that's why I want the sound to be, the visualization or the calculations to be worked out according to the seated position rather than standing. Okay, so I've done my preparation. I've got my graphic in place. I've got my audience areas in place. Now I can start adding loudspeakers, or as they're called in easeFocus, sound sources. So firstly, I click the sound source button, which looks like a line array. We're not dealing with line arrays, but the software definitely can do that. You can select the manufacturer. We've only got the three main ones in here. You can use other brands if you really must, but these are the ones that all of us should be focusing on, of course. So I've selected Apart Audio. I can choose the desired loudspeaker, so in this case, a Mask 6C. And I should also say at the top of this screen, there is also a search bar. So if you want to search for a particular loudspeaker, you can type it in there and it will find any matching loudspeakers. Now, once I've clicked OK on this screen, after I've selected the right loudspeaker, I then double click on the room, excuse me, on the room layout, and drop the speaker into the layout. So you can see here, the loudspeaker is represented by a square box. The line coming from the square box is the direction that the loudspeaker is pointing. And then below that, in the side view, you can also see how it looks from the side. So you can see that this loudspeaker is kind of halfway up the wall, and it's pointing directly straight into the room. So that's our loudspeaker dropped into the audience area or into the listening area. So from there, I can drag and drop the speaker. Oh, sorry, I beg your pardon, I just said it. Drop it into position. Then what I can do, however, is because it's very unlikely that I'm going to want this loudspeaker pointing directly at 90 degrees from the vertical. Similarly, I don't want it pointing directly straight out into the room. So what I can do is I can move this speaker visualization or representation, I should say, in the room in any way that I want. So if I grab the red box itself, I can move it into the room, anywhere in the room. Normally this is a cabinet speaker or wall-mounted speaker, so I'd mount it next to the wall. But then the lines that are emanating from the square, I can actually move those as well. So for example, on the upper display, I can grab that line anywhere along its length and move it up and down. And that will move the loudspeaker or the direction that the loudspeaker is pointing in the X and Y planes. Then similarly, in the bottom display of the side view, you see there's a line emanating from the loudspeaker again. It's the straight line in this case. If I grab that along any point along its length, I can then move it up and down, and that determines where the loudspeaker will be pointing in the Z axis. So whether it will be pointing down into the room or up into the ceiling, of course. The other line that is in that side view is a black line which changes according to the SPL within the room that's coming from the loudspeaker. So that allows you to see where the SPL of that room is going to be getting to in terms of a level, if you like. But the main things that are really interesting for you here are the colors, which allow you to determine how loud the loudspeaker is at any point in the distance away from the loudspeaker. So red is obviously very high level. You can see on the right-hand side, there is a scale with red at the top. So red represents 92.5 dB. And then the blue at the bottom represents 70. So obviously, the further away you get from the loudspeaker, the lower the level is going to be. So that hopefully gives you an understanding of how to add a loudspeaker, excuse me, and how you set up the space for accepting the loudspeakers in the first place. So if you have a loudspeaker selected within the room and go to object properties, you can set a label for the room. So this could be, for example, a label of the position of the loudspeaker or the location of the loudspeaker within the room. You can also set the height, its position in the X and Y axis in the design space, and also the vertical, horizontal, and rotation angles for the loudspeaker. So those things mean that you can position the loudspeaker very, very accurately within the room according to your requirements. And that's above and beyond just dragging and dropping the loudspeakers within the design. You also can set the gain. So for example, if you have a loudspeaker which is, well, ease focus only works with low impedance loudspeakers. So it doesn't know anything about 100 volts or 70 volts. So in this case, if you have a low impedance loudspeaker, which is 40 watts, excuse me, and you're using the tap at 20 watts, you can reduce the gain by 3 dB in this point here to accommodate the fact that it's going to be driven at half power. Once you've got a loudspeaker in your design and you've set the vertical angle, for example, so how it's going to be pointing within the room, rather than having to do that each time you put a loudspeaker in, you can easily copy and paste the loudspeaker so that you have more than one of them in the room. And that's a Control-C, Control-V operation, or copy and paste from the right click menu. Unfortunately, they don't support Control-D, which a lot of Windows programs do now. So Control-C, Control-V for copying. So we've got our loudspeaker in the room. This is a view of the software, a wider view. So the first thing you can see is on the right-hand side, it's got an image of the loudspeaker actually. So if it was pointed down within the space, you would see that visualization moving as well. Or if the loudspeaker was turned 90 degrees so it was horizontal, again, you would see that in that graphic. So in this display, the main part of it, you can see the higher SPL levels in red, the lower SPL levels in blue, and then the scale to the right. So this means that you can see how loud the sound will be anywhere in the room. You can move the loudspeakers around and see the effect of the sound within the room. You can turn off mapping to clean up the screen whilst, which will stop the calculations while you're just adding loudspeakers, and then turn the mapping back on later on. So this is just with one loudspeaker, but you'll see examples in a moment of multiple loudspeakers. So the lower part of the screen, the multi-tab display, if you like, this can be used for many, many things. So in this case, we're going to look at levels. So if I select a loudspeaker and click on the levels tab, what I can see here is how, or the sound pressure level of that loudspeaker as it moves away from the loudspeaker. So the left of the graph is 0, i.e. the speaker cone, and then it's measured in meters moving away from the loudspeaker, so up to 11 meters in this case. So you get a graphic here of how loud it will be the further you move away from the loudspeaker. If you select the space, i.e. you don't have a loudspeaker selected, then you get a view of the level versus the distance from the origin of the room. Now, the origin of the room is denoted by this arrow, which is in the center of the audience area. So in this case, the right-hand side is the origin of the room, and you're moving away from the origin. So the graph at the bottom will show you the SPL level as you move away from that origin inside the room. Then if I click on distribution graph, what I get here is an idea of the sound pressure level as an average within the room. So in this case, the red bar is representing 105 dB. So I can say roughly 55, 56% of the room is covered at 105 dB. So normally what we're looking for will depend exactly, or entirely on the purpose of the room. So if it's a cafe, for example, or a restaurant, you want relatively low SPLs. If it's a sports arena, you will want higher SPL levels to overcome the background noise, for example. But this allows you to see the distribution of the level within that space. It can be adjusted so that you're looking for half dB to 6 dB width, so depending on how accurate you want to go. You can also click on any of these bars, for example, the red or the yellow ones, and it will show you to present the accurate percentage of that that bar in the space. You can also see the average and standard deviation values for the room here as well. So that gives you a good indication if you're looking for something to be average above 105 dB. Then we can look at frequency response. So we've looked at the levels at any point in the room. We also will want to look at frequency response so that we can safely say that the quality of the sound, if you like, is as required at any point or in certain points within the room. So the way you do this is on the toolbar for the main view. You click on the little microphone, which is representing a receiver. So you can position the receiver within the room, either by dragging and dropping or by using the bars on the left-hand side or the entry positions on the left-hand side, so that you can accurately place the receivers within the room. Then if you click the frequency response tab at the bottom, you then get a view of the level versus the frequency at each of the receivers. So in this case, we've got two receivers, one blue and one green. And then on the plot at the bottom, you get a blue graph and then you get a green graph. So you can see the frequency response is slightly different between the two in this case. So you can think of this as similar to placing microphones within the space and being able to listen and analyze the sound coming from those microphones. You can also set a time response. So if the time delay is important in this room, it's relatively small, so it's not really that important. But if it's an outdoor arena or an outdoor venue, for example, with a large space between the audience area and different elements or different loudspeaker elements, then it could be quite important. So in this case, you will have multiple loudspeakers and at least one receiver. You click on time response and select the receiver over on the bottom right-hand side on the graph view here. And then the graph or the display will show you the level and the delay of each loudspeaker relative to that receiver. So for example, here it's showing me that the red bar graph is the origin, if you like. Then the next one is the mask 6C number 7, and it has a particular level and a particular delay, and so on as the loudspeakers move further away from the receiver. So that can be useful to work out if you need to accommodate any delays within your system to time align loudspeakers within a space. You can also add filters, so EQ curves to a loudspeaker within the visualization. So what you could do here is you could tune the loudspeakers for according to the tunings that are coming from a manufacturer, for example, so that will hopefully improve the loudspeaker sound within the space. So the way you do this, you have an individual EQ for each of the loudspeakers, which in real life would be applied by a DSP or a speaker processor or a simple EQ, rack mount EQ. So you can drag the gain, Q factor, frequency per speaker, and you have 4 parametric bands as well as a high shelf, low shelf, low pass and high pass. So quite good set of EQ to apply there. But note, this is just for the visualization, so it's not actually doing anything in real life. That has to be done by your DSP. But you can take these EQ settings and then duplicate them inside the real situation. There is also a global filter. So this is where all speakers are affected equally. So if you imagine the individual filters are for each loudspeaker, so that could be the tunings for a particular loudspeaker, but then you have one EQ which affects everything. So that could be, for example, for room EQ. So if you know you've got a particular problematic frequency within the room, then you can apply a global filter here. Right, then we've made our visualization. So we've worked out here. So this one is a project with a main room and then an ante room, for example. And I've put what, 4, 7, 8 speakers in there. So inside here, this is probably a background music system because it's what, 102, just over 102 dB average around the whole room. So everything is uniform, everything is even. There's a few little bits of yellow, which means it's slightly lower level, but it means you're getting uniform coverage across all of the seating area there, which in this case is what I'm looking for. It could be in other cases that you want a higher level at a certain part of the room and a lower level at another part, so you could move the loudspeakers or point them accordingly. So I'm happy with this and then can move on. Now what I need to do is create my report, which will go ahead along with my quotation for the project to allow the end user or the person you're selling to become confident and accept the design that you've made, and hopefully they give you the order. So to do this, on the main screen, you go to File, click Report, click the data to include. So I normally put everything in here. Maybe receivers is not so important on some projects, but it will depend on the project itself. And then you select the folder and the name to save. So this could be the project name, for example. Now you get a PDF report. So this is just the first page of it, but you get the idea that it shows you, oh, this one was done by my colleague Hans. So it's the project title is Ease Focus Initiation. So I guess he was doing a training. The author, his company name, the temperature, the pressure, the humidity, and the mapping, and so on. And then you get a drawing or a visualize or a representation of the space that we drew and the loudspeakers that are in there. Then later on in the report, you also get a list of all of the different sound sources, exactly where you need to mount them within the room in X, Y, and Z axis, and exactly how you need to position the loudspeakers in terms of horizontal and vertical angles, and then their rotation. And then you get a distribution graph and if any filters were applied. So that is really useful stuff, not only to help you get the project, but once you're installing the project, it will actually allow you to use this as a plan for where the loudspeakers need to be installed. Question from my colleague Neville: can you export into any other format apart from PDF with the light version, or do you need to do this with the standard? Yes, it does only export as a PDF. I'm saying that, but I am actually just going to try it. I have the software open here as well. So File, Create Reports. Okay. No, for some reason my Ease Focus is not operational. I will come back to you on that, Neville, but I'm pretty sure it's only PDFs. So that's the process of getting a project, getting the software installed, getting the GLLs, making your first project, putting in a graphic, and placing the loudspeakers. So what I'm going to do now is go through a few system examples that we've made within the past couple of years. So this is a real project in Amsterdam of a showroom area. It's actually a multi-purpose area because it was a car showroom, but also they used it for events in the evening and then also small meetings as well. So it's quite a small area. It's what, probably 15 by 10 meters or so. And it has a bar area, a lounge area. The car box is where they do a presentation or a discussion about the product that they're selling. And then there's a range wall area. So in this case, the bar and the lounge area, they wanted to have the capability of being quite a loud level, which is why we use so many loudspeakers there. And then we had 4 speakers covering the other end of the room. Note also that the entrance area on the left-hand side here, we purposely left it so that there's hardly any sound there, so that when people come into the venue, they're not blasted by sound and it's not causing pollution out onto the streets and so on. Similarly, the range wall area, when people are browsing there, they don't really need high pressure sound there as well. So in this case, we solved this with what I think 8 Mas 6C loudspeakers, an amplifier, preamplifier, and a music source. And that was a really nice little system. Another one actually worked on by my colleague Raf. This was a retail outlet called Only in Hamburg. So this one was a little more complex because it had quite a few different little spaces here with a good number of loudspeakers, what, 12, 14 loudspeakers here. But you can see here that we position the loudspeakers so that there were a few hotspots around some particular areas. But also on the lower right-hand section, that's where the cache desk is. So we didn't want to put a lot of sound pressure there so that people working there were not getting fatigued from the amount of sound that was there all day long for when they are. But this was high enough SPL and performance to create the atmosphere of a retail clothing retail outlet in this case, and quite well received from what I understand. This is a stadium. There's an example by my colleagues in community. So here you can see a much larger environment, a big football stadium in this case, or soccer stadium. And they've got different areas of the terracing and then loudspeakers covering each of the individual terracing and the upper tiers as well. So a large number of loudspeakers, and if you consider you've got, what, 22% coverage over 108 dB and the remainder at 105, that is pretty uniform coverage for an area where the loudspeakers are probably, what, 20-25 meters away from the listening area. So pretty heavy performance from the big community loudspeakers there. But this allows these visualizations to be used and give confidence of the solution is going to solve the problem. Just got a question in from Ben. Which way should the arrow in the audience area point? That's a good question. So in this case, the audience area is pointing, the arrow is pointing from the back to the front of the audience area, and the loudspeaker in this case is pointing in the opposite direction. So the only reason it's relevant is when you start to start looking at the graphs of how loud it is when you're at the back or the front of that listening area. So then it just identifies which is the back and which is the front of the graph that you're using. So I would say in this case, it's important to have them all the same so that when you're switching between audience areas, you are always looking at the same thing. But in reality, it doesn't actually matter so long as you know how to interpret them. And that is that the arrow points away from the source of the room. So hopefully that answers your question, Ben. Right, so then we're going to move on to the next one, which again is a community one. So this is quite, well, for community, quite a low level, 102, 105 dB, but this is quite a large space in a house of worship area. So 105 dB in there, but that's only from 2 loudspeakers in the main area of the church, and then there's another separate area which is for, I guess, for a baptism or music performance or something. So again, just 3 loudspeakers, but very high performing loudspeakers to cover this whole area. So this allows you to point the loudspeakers and then adjust accordingly to make sure that you get the correct coverage and the correct performance before you even go to the site, or even if it's built. So, but needless to say, a site survey is always great because this plan or this drawing may well give you a good idea of how the space is physically, but it may not always show you, for example, pillars or spaces in the room where something else is there. So it's a good idea to always do a site survey or get photographs as much as possible, or drawings of how the room will be if it's not built yet. But this gives you a great starting point. So some final thoughts. Some applications will benefit from more lower powered speakers and for even coverage. So I'm thinking about restaurants and retail here. So you often find a lot of ceiling speakers or a lot of wall speakers all mounted around the perimeter of the space. And that's so that you get lower SPLs, but more even coverage within the whole area. Also, sometimes consider low-level areas, for example, the serving desk of a retail store or a cafe, for example, or a coffee shop, or the entrance doors, so that it doesn't cause fatigue for the people working there. Remember, Ease Focus does not consider any reflections, so you're going to get a good estimation of how it's going to be, but a site visit will also help you understand if it's a reverberant space. So if it is reverberant space, you may need to go up to Ease Focus, the full version of Ease to get a really accurate visualization, or you may need to plan accordingly by reducing your SPL levels, knowing that the reverberant area is going to cause an increase in that. And as I just said, if the room is reverberant, the actual sound will be very different to the model. So from our side, what we can help you with, we've obviously invested in the GLL files for most of our loudspeakers. We will continue doing that in the future because it's a great service. We can also support you. So we have members of staff who can use ease focus. We also have ways of getting full ease simulations made for you. So we're ready to help you. We can offer support in many ways. Firstly, we can help you get started. This webinar hopefully has been useful for that, but we can also give you one-to-ones on focus if you need to for small and medium-sized projects. So normally you can work on those projects yourself with a little bit of help at the beginning. We can also assist with larger project designs as required. So if you need that, then you can reach out to us either via your account manager or support@biamp.com. In general, the information we need to make a project along with your help, and it's important to understand that you own the project, so you are responsible for the project even though we're helping you with it. So the goals, so the SPL requirements, the frequency response, the coverage requirements, the general idea of what it is it loud, high-level background music, voice, retail, bar, sports arena, and so on. Ideally, plan view graphic of the space with scale, 3D views of the space so that we can work out anything else that's in the room that needs to be avoided. Any guidance from your side. So for example, if you're overseas from where we are, you would need to go and do a site survey, take images and get guidance from your own knowledge or from the customer about where speakers could be and could not be placed because of obstacles and so on. Another thing to add, we've gone through ease address and ease focus a little bit, but we do have some other design tools which you will find very helpful. So support.biamp.com in the design tools section, there is in fact a ceiling loudspeaker calculator. So this is nothing to do with ease address, ease focus and so on, but it is a very cut down way of working out how many loudspeakers you would want, or ceiling loudspeakers I should say, you may need in a simple conference room, for example. So in this case, you just enter the dimensions of the room, the loudspeaker model that you would like to use, or I beg your pardon, you enter the size of the room and it suggests the different loudspeakers that could be used for that project. You can choose the ones that you think would be right from your side, or the ones that you know you have or you can get. And it will give you a very basic visualization of the SPL level within that space and an estimation of how many loudspeakers to use. So it's quick and easy. Maybe you could use that as a first step and then also put it into ease address or ease focus and get a more accurate or a better visualization of the whole space, for example. All right, so I think that's about it for now. Just a reminder, there's a couple of other webinars which we have. So on August the 26th and the 27th, or if anybody really wants to, I'm doing this webinar again tomorrow evening, UK time. So, but then on the 26th and 27th, there's another webinar which concerns itself with constant voltage loudspeaker systems, i.e. 70 and 100 volt loudspeaker systems, in other words. You can also at any time see all of the webinars we have on offer and register for them at biamp.com/training/webinars. And you can get details of planned webinars, but also the recordings of previous webinars in there as well. So it just leaves me to say thank you for attending and your time. Very much appreciated, and hope you keep well and keep safe, and hope to see you or hear from you soon. Thank you. Bye-bye.